Hi everybody, welcome to Algebra 1, Day 2. We're going to continue through our distance learning, but by continuing, we're actually starting actual algebra work today. So we're going to be working in Chapter 7. We will start with Chapter 7, Section 1, and we will be studying exponents and power rules during this chapter. And so right now, what you need to have with you is your textbook and the note handout if you decide to print it off from the email or from fax RenWeb, or paper to take notes. And get that ready. If you don't have it ready, go get it right now. Pause the video and go get it right now. And it'll be on page 414. So the first thing that we're going to talk about is just reviewing a little bit of basic understanding about exponents. And you'll see this in the book on page 414 as well. But we're going to go ahead and just fill in some numbers and do the math here. Whenever I see 2 to the 4th, we know that means I take that 2 and I multiply it by itself 4 times. The power tells me how many times I multiply it, and this number, whatever's being raised to that power, is called the exponent. Or excuse me, it's called the base. That's the base. The base is what's being multiplied. The exponent tells me how many times. So if I'm going to fill in this chart and figure out the math, 2 to the 4th is 2 times 2 times 2 times 2. So far, so good, right? So if I do that math, I know that 2 to the 4th is 16. I'm going to continue moving along. 2 cubed means I'm not going to do it 4 times. I'm only going to do it 3 times. And so that answer is 8. So be filling this out on your handout or taking notes right now on your paper. 2 squared is 4. And 2 to the first power means I'm not multiplying it many times, just one time. How many 2's do I have? I have 1. So 2 to the first power is 2. I want to stop right now, though, and talk about the pattern that you see. We've done this many times in this class. What do you notice is happening as we go through these numbers? 16, 8, 4, then 2. We see that there is a pattern, and the pattern is I'm actually dividing everything by 2. And that's important as we move into the next steps. And you're going to see 2 properties of exponents emerge just in this table. And those are the 2 that we're going to cover today. If I continue along in this pattern, 2 to the 0 power, don't be thrown. It does not equal 0. I need to be consistent and follow the pattern. 2 divided by 2, however, is 1. So we see that 2 to the 0 power is 1. Let's keep going. Continuing the pattern, 1 divided by 2 tells me that 2 to the negative 1 power is 1/2. And I know these numbers are getting pretty small. 2 to the negative 2nd power is 1/4. So if we're following those patterns and filling in those charts, we see 2 rules emerge. So I'm sorry if that was blocking your view. Right here is the first first property that we're going to discuss. Anything raised to a 0 power is 1. Any non-zero number raised to the 0 power is 1. The second concept that we see is what happens when we go down into these negative exponents? Well, you notice when I do that, I have numbers in my denominator now. So we're going to be talking about that too. Here is where we see our 2 properties for today emerge. I'm going to go ahead and clean my board so that we can move into that specifically. And as I do that, I do want to talk about, it is March 26th. It's Thursday. It's a beautiful spring day, so I hope you'll be able to get your work done and head outside. I also know that yesterday could have been a little overwhelming for some of us as we start all of this craziness. I appreciate those of you who were really diligent about watching my video and getting in all of your tasks and your assignments into me. I loved communicating with each of you yesterday, even if it was with a couple words through email. But I will say that at 9:10 a.m., there's still a good amount of you who have not finished your tasks, and they are due at 10 a.m. When we are moving forward in distance learning, I stressed this in the video yesterday, you have got to be on top of your own responsibilities. And when I give a due date or a due time, I'm sticking to it. So you need to be making sure you are doing all of the work that you need to do and get it done. Okay, so let's talk about the first property, the property of the zero exponent. We write that property like this. For any non-zero number a raised to the 0 power, it equals 1. Notice I'm being very specific and saying a non-zero number. We're going to get to that in a second, but what I can establish here is a really easy pattern that anything raised to the 0 power that is not 0 equals 1. And you can look on your notes and in your book, there are examples there that I don't feel like I need to write out on the board. 4 to the 0 power equals 1. Negative 3 to the 0 power is 1. 5.14 to the 0 power is 1. Doesn't matter how large the number, how small it is, if it's a fraction, if it's a decimal, if it's raised to the 0 power, it equals 1. Now, why doesn't 0 work? Well, look at this. 0 cubed means I'm taking that base of 0 and I'm multiplying it by itself 3 times. Well, we know that as soon as you have 1 0 in there, it's going to be 0. But for the sake of our argument here, 0 cubed is still 0. 0 to the 99th power is 0, which means that 0 to the 0 power is still 0. That's why this rule only applies to anything other than 0. If it's raised to the 0 power, it equals 1, except for 0. 0 to any power is 0. Okay, that is a distinction that needed to be made. I'm going to erase our 0 work and then talk about our second property of the day. This is property number 1, and it's written out in more detail in your book and on your notes. Our second one is, what do we do with a negative exponent? Well, you saw that in the chart that we filled in with our 2's. Anytime we have any number raised to a negative exponent, what that means is we write that in the denominator of a fraction. That means it turns into 1 over that number raised to the positive exponent. We are taking that power, we're kicking it into the denominator, and it becomes positive. So what we did in that chart, let's refer back to that. You see it on your paper. I'm going to show it to you again on the board. 2 to the negative 1 meant I made that 1 over 2 to the positive 1, which I'm going to write that there. But remember, anytime our exponent is 1, we really don't need to include that. So I could erase that too. Oops, blue. Let's go ahead and show this example. We did this one together in the chart. That means if I see a negative exponent, I immediately write 1 over, and I kick it to the basement or the denominator, 2 squared, which if you remember in our chart, we had 1/4. So that's correct. So anytime we have a negative exponent, it moves to the denominator of a fraction. 1 over that positive power. Okay? So there are a few examples in your notes and in the book that I'm going to take the time to talk about here. So let me clear this a little bit. These markers are a little bit hard on this whiteboard, so you can still see that. The few examples that we see here, 7 to the negative 3rd power. And this are the first 2. Okay, 7 to the negative 3rd. As soon as I see that negative exponent right there, I know I'm going to write 1 over 7. My base is not changing. But then my exponent is no longer negative 3, it's now positive 3. So that equals 1 over 7 cubed. Okay, we don't need to figure out how big or what that number is. It's pretty big. In this case, I want to point out here a very important rule about exponents. Remember that an exponent only refers to what is immediately in front of it. So if I have parentheses, though, that means this whole negative 5 is being raised to that exponent. That's going to help me write this answer correctly. As soon as I notice that negative exponent, I know I'm going to make it 1 over, that negative 5 is still going to stay in parentheses, but my negative 2 exponent is now going to become positive 2. Well, then I can simplify that. Negative 5 squared is negative 5 times negative 5. So my answer here is 1/25. Okay? Let me do one more. And we're going to talk about this next one again, but it is worth mentioning a few times. What if I had this situation where I have a negative exponent, but this time it's already in the denominator? Well, what really is happening here is if I have a negative exponent, I am switching it. So if it was in the bottom, it now becomes positive in the top. So this now equals 25. So a negative exponent, if it's in the numerator, we make it positive in the denominator. If it was negative in the denominator, we make it positive in the numerator. So we're just switching it. Okay? Any questions on that? Save them for Zoom, but what I want you to do right now is to pause. Nope, just kidding. We're going to keep going as I'm looking at my notes. That's why they're there. Okay, problem number 1. Let's just review the 2 things that we learned here with 2 more example problems. I have 9 to the negative 2nd power. That means I'm going to notice that negative exponent first, and following this property, that becomes 1/9. My base stays the same, but now my exponent becomes positive 2. And I can go ahead and simplify that. And it becomes 1/81. Okay, the next one that you see in your, or on your notes. All right, you guys want a little bit of real life action here? Hold on one second. I do remember recording, and I can hear you in the background. Remember we talked about that? All right, that's real life here for you guys. We have lots of people, lots of Zooming, lots of talking, so I had to send a kid somewhere else. Okay, our next example is letter B in problem 1. In this case, we have negative 3.6 raised to the 0 power. Remember our first rule? Anything besides 0 raised to the 0 power is 1. Those are nice because if I recognize right away that my exponent is 0, I actually have to do no work at all. It equals 1. Okay, what I want you to do now is pause the video and try the 5 practice problems there under problem 1. If you are just following along in your book, they're the got it problems under problem 1. If you're following the note handout, they're typed there for you. So pause the video and then we'll go over them. Let me move this out of the way. And here we go. Okay, if you are listening to me right now, hopefully that means you have already finished these problems on your own, and we're going to go ahead and take the time to talk about each of these. The first one, 4 to the negative 3rd power. My first property, or my second property that we talked about, the negative exponent, means that I simply take that 1/4 cubed. Now when the numbers are small, like this, we can go ahead and actually solve what that is. And I'm going to squeeze that in there. 1/48. Because if I cube 4, that's 4 times 4 times 4. Wait, did I do that right? Haha, isn't that funny? 16 times 4. I did that wrong. It's 1/64. Haha. There you go. There's some real life for you there too. I do that in the classroom all the time, get things wrong. So why would I do it any differently in the video? The next example, moving along to number 2, negative 5 to the 0 power. Remember, I don't really have to think about that a whole lot. I recognize my exponent is 0. That means my answer to number 2 is simply 1. 3 to the negative 2nd power. Again, I'm recognizing a negative exponent. That becomes 1 over 3 squared. And I know what that is. I would simplify it all the way to 1/9. Number 4, 6 to the negative 1 power. Negative exponent, bumps it to the bottom, and I don't need to write that exponent of 1. Negative 4 to the negative 2nd power means I'm going to bump that. My base of negative 4 is going to stay in the parentheses, but now it's going to become positive 2 in the denominator. Well, I can also clean that up. Negative 4 times negative 4, positive 16, 1/16. The last one you'll notice isn't in the book and it's not on the handout. It's just one that I was thinking, we really need to talk about this because this is going to come up as we move forward in these problems. Remember that I said my exponent only refers to what is immediately in front of it. In this case, I do not have parentheses around this negative 5. So what is being raised to the 0 power? Just the 5. So I can think through it like this. There's my crooked parentheses. I need to figure out, well, 5 to the 0 power is 1. Then I take the negative. So the answer to this problem is really negative 1. Remember, exponents only refer to what is immediately in front of it. If I have parentheses, it takes the whole thing. If I don't, I raise 5 to the 0 power to get 1, and then I take the opposite. So you see that these two problems look a lot alike, but they have the opposite answer. Okay, let's move on. Problem 2. We're going to make it just a little bit harder. You're going to have to think through these power rules a little bit more. Let me clear my board and bring that up. In fact, it's a little bit easier if I do it this way. And actually, I'll write both of them out right now. And again, we are going to be practicing what that means to have multiple terms in these problems and how we kind of deal with them chunk by chunk. So letter A, I need to simplify this. They're actually saying, what is a simplified form? That means I go through and I clean up anything that I can clean up. So in my first one, I see a 5, a cubed b to the negative 2nd. Well, the 5 is simplified. Nothing really I can do with that. A cubed, I can't really clean that up because I don't know what a is. But this b to the negative 2nd power. I can simplify that a little bit. Meaning simplified forms do not have negative exponents in them. So I see that negative exponent and I need to deal with that. Remember, this negative 2 only refers to the b. So if I were to rewrite this the first step, that 5 and that a cubed would stay the same. Then I would deal with this b to the negative 2nd. Well, I know that that is 1 over b squared. Because what operation's happening here? Multiplication. It's here and it's here. But we don't write that anymore. But I need to think that that's what's happening, that I'm multiplying. So if I do this and I multiply straight across the top, the simplified version of this looks like that. I took the part that had the negative exponent, I bumped it into the denominator and made the exponent positive. This is the simplified version of that. Let's look at the next one. We did one like this already. In this case, there's only one thing I need to think about anyways. I see this negative exponent, but it's in the denominator. So to deal with that, remember, my simplified forms do not have negative exponents. I need to take that negative exponent, bump it up, and make it positive. So 1 over x to the negative 5th is just x to the 5th. See how this is a lot more simple than that. We like it like this instead. Okay, I want you to pause the video again and try the 5 practice problems there under problem 2. Do those quickly, not quickly, take your time, but pause the video because I'm not going to leave time for it. I'm going to clean my board and write those so that we can go over them. I have a lot to squeeze on here. That's okay. All those times in class that you hung out while I was writing things on the board, it's still happening. Okay, now hopefully I can do all of these on this one whiteboard. Okay, at this point, you should have finished these 5 problems on your own. So let's go over the answers. Simplifying this. Simplify means I don't have any negative exponents, so I need to deal with those. So if I see x to the negative 9, recognizing that there's my negative exponent, I'm going to make that 1 over x to the positive 9. There's nothing more I can do to simplify that one. Looking at the next one, I see I have a negative exponent, but it's in the denominator. So to simplify that, I make it positive and bump it up. So this one is simply n cubed. The next one, remember that rule, this is number 3, that this exponent right here only refers to c. It does not mean 4 is being raised to the negative 3rd power. It does not mean b is being raised to the negative 3rd power. Only the c is. So I'm going to take that c and I'm going to bump it to the denominator, making the power positive. But these two are going to remain the same. I didn't change anything about those. Those are going to stay in the numerator. Only the parts that have negative exponents get switched. Okay, looking at the next one, number 4. Again, I have 2 parts to this. I have a 2. That's simplified. But I have this a to the negative 3rd power. Recognizing my negative exponent, I'm going to leave that 2 in the numerator. But guess what? This is going to bump up the top 2, or as well, and become a to the positive 3 power. Looking at the final one, this n squared in the denominator does not have a negative exponent, so it's fine where it is. However, this one in the numerator has a negative. I need to deal with that. So that's going to go to the bottom. M squared is already in the denominator. Now I'm going to have n to the positive 5th power. Well, what goes in my numerator? 0? No, it's now 1 over that entire quantity. Okay, if you have questions on this, save them for Zoom and we can address this. Read in your book, refer to your book, and as I've been saying, use that Khan Academy. Khan Academy, when you get into it, you can put in there exponents, and they have so many other tools available for you to watch other videos of other people doing exactly what I'm doing, working on a whiteboard and demonstrating to you, but maybe hearing it again from a different voice, a different perspective is going to help explain it a little bit better. So don't be afraid to test that out. Okay, I'm going to take a drink here, and then we're going to do our last problem of the day. Okay, problem 3, evaluating an exponential expression. All right, we have evaluated expressions all year long. We haven't done too many with exponents in them as far as dealing with combining with these power rules that we're talking about. So I'm going to go ahead and demonstrate this one. And I'm going to demonstrate it 2 different ways. And this is problem 3 in your books. It's shown exactly the same way, also demonstrating it 2 different ways. Okay, this is my expression, my exponential expression. Means it has an expression that has exponents in it. There's no equal sign. It's not an equation. I'm not solving for a value or a variable. It's just an expression. So if I need to evaluate an expression, I'm going to take values and plug them in. So I am told in this problem that, I'm going to write it up here, s equals 2 and t equals negative 3. There's 2 different ways I can approach this problem. And you are welcome to choose whatever method works the best for you. So step 1, or of method 1, this one I'm going to go ahead and simplify first. Meaning I'm going to clean up my negative exponents first. Then I'm going to plug in the values. Okay, so first I'm going to deal with that t to the negative second. 3 is fine, s cubed is fine, but I'm going to take that t to the negative second, change that to a positive and bump it to the denominator. So that's the cleaned up, simplified version of this expression. Now I'm going to take these values and plug them in. And I'm going to do that with my whiteboard. And remember, parentheses. You have to use parentheses to make sure you don't lose the corrective meaning of this negative number. So look what I'm going to do. Just for the sake of whiteboards, I'm going to plug in 2. And I know t equals negative 3. So using parentheses, I'm going to plug in negative 3. Now, remember our order of operations. This is where I know a lot of students make mistakes. I'm not going to do 3 times 2 and then cube it. Remember, exponents come first. So I'm first going to say 2 cubed, which is 8, times 3 is 24. Then I'm going to do the same thing in my denominator. Negative 3 squared is negative 3 times negative 3, which is positive 9. So order of operations, 2 cubed is 8, times 3 is 24, over negative 3 squared is 9. And then I can leave that, remember, I can leave that as an improper fraction, but if it can be reduced, I should do that. Can this be reduced? Sure, both of those numbers can be divided by 3. So, 8/3 is my final answer. I'm going to go ahead and show you the second method right next to it. This time, I'm just going to flip-flop the order. Instead of simplifying first, I can plug in these numbers first and then simplify it. So, that's what I'm going to go ahead and do. I'm going to take that 3, my s is 2, so see how I'm plugging in the values first, then I'm going to clean it up. So what I'm going to do here is negative 3 to the negative second power. Well, I know that means that negative 3 gets bumped down and how it has a positive power of 2. So you'll notice that depending on what I do first, I'm still going to end up at the same exact spot. Order of operations, 2 cubed is 8, times 3 is 24, over 9, reduce it to be 8/3. Okay, you can choose whichever method you want to do first. Clean up, then plug in, or plug in, then clean up. Either way, you're going to get the same answer. I want you to pause the video and try. There are 4 practice problems there for you to do with 2 different values for N and W. You see it in your book, the Got It problems under problem 3, or they're on the note handout. So go ahead and pause the video, try those 4 on your own. Let me clean this up. I think I'll only be able to do 2 at a time on the board. You'll notice some other things are being added into the mix here. Yeah, we'll just stick with the first 2 and then we'll do the second 2. So at this point, you should have completed all 4 of these practice problems and we're going to go over the answers. I have 2 different expressions here. This is number 1 and number 2. These are my values. And again, remember you have a little freedom here, what you want to do. I like to simplify first. Because if you plug in your numbers first, you might end up doing unnecessary math. So my way of doing it is simplifying it first, cleaning up things that we know to be simplified, and then plug in the values. But please do remember, you have the option to do it the other way around. So I'm going to do that. If I see this n to the negative 4 and w to the 0 power, what can I clean up from this? Well, I see one thing right away. Anything to the 0 power is 1. Remember that operation happening there is multiplication. So that means it's really n to the negative 4 times 1. Well, anything times 1 is itself. So guess what I can do? When I'm multiplying, it just means I have n to the negative 4th power, which I know I bump that to the denominator. Now I'm ready to plug in that value of negative 2. Now, you can use your calculator for these, of course. You're going to either figure out negative 2 times negative 2 times negative 2 times negative 2 4 times. Or you'll see on your calculator these buttons. This is where we pull in exponents. You will also see this button. In fact, most of your calculators use this. This is a caret. And if you wanted to plug this in your calculator, you would type negative 2 caret 4. And then you should get that we have 1 over positive 16. Because I'm multiplying a negative number an even amount of time. So I know that my answer is going to be positive. So the answer to the first practice problem is 1/16. Take a look at the next one. Again, I prefer to clean up first. So this negative exponent is going to move to my denominator. It becomes n to the first power. Well, anything with the first power is itself. I don't need to write it. Now that I have it simplified, I can go ahead and plug in my numbers. N equals negative 2. W equals 5, and I'm squaring it. Remember your order of operations here. I do not multiply these together and then square it. I have to do my exponent first. 5 squared is 25 times negative 2. We get negative 1/50 in this problem. And you might say, well, wait a minute. My negative was on the bottom. That equals the same thing. Whether I put my negative sign top, bottom, or some people do it right out front. All three of those mean the same exact thing. Okay, let me clear my board and we'll do the last 2 problems for today. And that is your practice problems number 3 and 4 that I was right to assume I didn't have room for on my board. Okay, so number 3, we have n to the 0, w to the 6th, and then we have 1 over. Okay, so again, my preference is simplify first. Clean up the things you see. And then the first problem, which is number 3, I see that I can clean this situation up. Anything to the 0 power is 1. So my real problem that I'm dealing with is 1 over w to the 6th power. Now that it's cleaned up, I can take that w, plug in a 5. 1 over 5 to the 6th, which I can leave that like that. That's a pretty big number. So I'm going to leave it just like that, 1 over 5 to the 6th. Last one, clean up what I see. This has a positive exponent. It's going to stay right where it is. This has a negative exponent. I'm going to bump that to the top. So rewriting that, I get w to the 1st power, which I don't need to include, over n. I took this and I moved it to the top, making that power positive. Well, now that it's cleaned up, it's a little bit easier to plug in those numbers. W equals 5, n equals negative 2. Negative 5 halves is my answer. Remember, bottom, top, doesn't matter. I can even, if you wanted to, say, well, we know that's 2.5, but remember, mixed or improper fractions are fine. If you want to be even more specific with a decimal, 2.5, that's fine too. Okay, so here we are. what I need you to do now, this is the conclusion of our first official Algebra 1 lesson. That one was pretty long. Tomorrow's, or the next one I'm going to do, which I'm going to do later today, is not going to be this long. I know there was a lot thrown at you, but you took notes during this session, you have your book available, and you have practice problems to do. So the suggested problems are written on your handout. They're also posted in facts. Remember from my video yesterday that I said suggested problems mean something different than they did in the regular classroom. That means they are tools given to you to practice what we just learned. I'm not going to collect these. I'm not going to check them. This is all for your benefit. So on page 417, I'm going to write it down for the sake of those of you who are visual people. On page 417, numbers 9 through 41 are the ones that cover exactly what I talked about in this lesson. Every other odd, meaning there's a lot there. You don't have to do all of them. You can just start with a few at the beginning, try a few at the middle, and a few at the end. Make sure you're hitting some of every type of problem, but because they're odds, you can check them in the back. Once you then feel comfortable with this, go on to Khan Academy, and I will have assigned your quiz or your homework practice problems, just like you did in the practice yesterday. Those were really hard, weren't they? That will just make sure you're on the same page. You're feeling really comfortable with this process. Now, if you're watching this and you have not received an email from me saying you completed your tasks from day 1, you won't see this quiz in Khan Academy for you yet. You have to finish your work that was due today at 10 in 15 minutes before I can assign it. So make sure you are finishing your work from yesterday first. Okay, so the practice that you will see is called this. And again, this is on your handout. You'll see this show up. Practice negative exponents. It's going to be a short quiz between 4 and 7 problems. Excuse me. And that's how I'll know that you watched this video, you completed your practice problems, and you're feeling really good about it. Okay, stay tuned for more information coming to you today. You got a lot of emails from me yesterday and last night. Please be checking your email. Please be checking RenWeb and Facts, and have a great day. Bye.